Hi folks, Joseph Kursky here with you to talk about spatial and temporal analysis with invasive species. Here, zebra mussels on a beach I used to walk on as a kid. Now it's piles and piles of zebra mussels. Very grim situation, not only here but in many other parts of North America. Let's take a look at the data inside ArcGIS Online. This comes from the U.S. Geological Survey, and it's got multiple years and multiple sightings of zebra mussels. Now I can look at using the filtering tools and the style tools inside ArcGIS Online. I can look at these and also the animation tools by year. I can also make a chart, as you saw me do just now, by year. Count, very simple chart, but effective. I can look at the Esri World Hydro layer and see which waterways are affected, and each watershed also in these dotted brown lines are the watersheds. Now I'm going to sign into ArcGIS Online and go a little bit deeper here. Why am I doing that? Because I can access the analytical tools. But before I do that, I'm going to filter the data on the year before January 1, 2000. So now I'm going to use a tool, and I love these center, mean center, standard deviational ellipse tools. Mean center and ellipse. I'm going to use both of those. I'm going to give it a meaningful output name. Be organized about your data, as I'm always saying in these tutorials. Processing sent, full extent of the data. Now I've got a mean center and a standard deviational ellipse for all the zebra mussels, thousands of zebra mussel sightings before 2000. So basically from the mid-1980s to the end of 1999. Okay, I'm going to go ahead and label. Actually, what I'm going to do is I'm going to create a sketch layer. I'm going to create a sketch layer with the text mean center before 2000. Now I'm going to filter the data. You probably know where I'm going next, is greater than or equal to 1/1/2000. Because I don't want to exclude January 1, so I'm going to say greater than or equal to. And again, I'm going to give it a meaningful output name. Let's look at the history here. Okay, succeeded. View analysis history if we want to see that. Great. Now we've got two different shapes, don't we? And two different mean centers. Notice how the mean center drifted southwest, actually west-southwest. So I'm going to go ahead and use the same technique in my sketch layer, mean center 2000 and after. Also notice in a moment that I have access to the table of data. So I could also create a calculated extent, so I know exactly how big those one standard deviational ellipses are. Now, we could have another discussion about, is it really appropriate to use Web Mercator for this? Probably not. I probably want to project it into Albers or something like that. But the point is, you've got access to the data. You just calculated the standard deviational ellipse. You could calculate the area for both of those things and actually get a shape estimation, also how close either one of those was to a perfect circle. Interesting. So it changed location of the standard deviational ellipse, but it also changed the shape, and the mean center moved. Why? Because the zebra mussels have migrated from the Great Lakes to other waterways in North America. Grim situation, but hopefully the analysis of this particular invasive species through GIS can help us to turn the situation around, which is the goal in all of GIS, is to actually take action and do something about it. Thanks for being with me, and I hope that nudges you into, hey, I can use ArcGIS Online, WebGIS, for teaching core concepts in GIS, sure, but also about foundational principles of environmental science, invasive species, and the spread over space and time. So we're teaching skills, we're teaching concepts, and we're teaching holistic thinking about, okay, this is a complex situation. How are we going to turn the situation around? Thanks for being with me.